Big data has become a buzzword in recent years, used to describe large and complex sets of data that are beyond the scope of traditional data processing systems. The concept of big data has emerged as a result of the exponential growth of data generated from various sources, such as social media, online transactions, sensors, and machine-generated data. The term big data is generally used to describe data that is too large, complex, or dynamic to be processed using traditional data processing techniques, such as those used in relational databases or spreadsheets. Big data is typically characterized by the three verses: volume, velocity, and variety. Volume refers to the sheer amount of data generated every day. For example, in 2020, it was estimated that the world generated 44 zettabytes of data, and this number is expected to increase to 175 zettabytes by 2025. To put this in perspective, 1 zettabyte is equivalent to 1 billion terabytes. Velocity refers to the speed at which data is generated, and how quickly it needs to be processed. For example, social media platforms generate billions of posts, comments, and likes every day, all of which need to be processed in real time to keep up with the fast pace of social media. Variety refers to the diverse range of data types and formats that exist, such as text, audio, video, and images. This data can be structured, semi-structured, or unstructured, making it difficult to process using traditional data processing techniques. The importance of big data has grown significantly in recent years, and it has become a critical factor in business decision-making. Big data analytics can provide insights into customer behavior, market trends, and other business-related information that can be used to improve decision-making and gain a competitive advantage. For example, retailers can use big data analytics to analyze customer data and personalize marketing campaigns, while healthcare providers can use big data analytics to improve patient outcomes and reduce costs by analyzing large amounts of patient data to identify trends and patterns. However, big data also poses significant challenges. These challenges include data quality, data privacy, and security, data storage, and processing, and the need for specialized tools and techniques to analyze and make sense of big data. Data quality. One of the biggest challenges of big data is ensuring data quality. Big data sets are often generated from multiple sources, and the data may be incomplete, inconsistent, or contain errors. Poor data quality can lead to inaccurate insights and poor decision-making. To ensure data quality, organizations need to implement robust data quality assurance processes. These processes should include data cleansing, which involves identifying and correcting errors and inconsistencies in the data, and data validation, which involves verifying the accuracy and completeness of the data. Data privacy and security. Another major challenge of big data is data privacy and security. Big data sets can contain sensitive information, such as personal data, financial information, or confidential business data. As a result, organizations need to take steps to protect the privacy and security of the data. This can be achieved through data encryption, access controls, and other security measures. However, ensuring data privacy and security can be challenging, especially when working with large, complex data sets that are generated from multiple sources. Data storage and processing. Storing and processing large data sets can also be a significant challenge. Traditional data processing systems are not designed to handle the volume, velocity, and variety of big data, and as a result, new technologies and techniques are required. One approach to storing and processing big data is to use distributed file systems, such as Hadoop, which allows data to be stored and processed across multiple servers. Another approach is to use NoSQL databases, which are designed to handle unstructured and semi-structured data. Specialized tools and techniques. Finally, analyzing and making sense of big data requires specialized tools and techniques. Traditional data analysis techniques, such as statistical analysis and data mining, may not be sufficient for handling big data. New techniques, such as machine learning and artificial intelligence, are increasingly being used to analyze big data. These techniques involve training algorithms to identify patterns and relationships in the data, and then using these patterns to make predictions and recommendations. One example of the use of machine learning in big data analytics is in fraud detection. Financial institutions can use machine learning algorithms to analyze large amounts of transaction data and identify patterns that may indicate fraud. Another example is in predictive maintenance, where machine learning algorithms can be used to analyze sensor data from industrial equipment and predict when maintenance is required, reducing downtime and improving efficiency. Overall, big data has the potential to revolutionize the way organizations operate and make decisions. By analyzing large and complex data sets, organizations can gain valuable insights into customer behavior, market trends, and other important business-related information. However, realizing the benefits of big data requires overcoming significant challenges, including data quality, data privacy and security, data storage and processing, and the need for specialized tools and techniques. In addition to the technical challenges, there are also ethical considerations to be taken into account when working with big data. The collection and use of personal data can raise privacy concerns, and there is a risk that data could be used to discriminate against certain individuals or groups. To address these challenges, organizations need to establish strong data governance policies and procedures to ensure that data is collected and used in an ethical and transparent manner. This may include obtaining explicit consent from individuals before collecting and using their data, implementing strong security measures to protect sensitive information, and regularly monitoring and auditing data usage to ensure compliance with regulations and ethical standards. Another challenge is the need for skilled professionals who can work with big data. As the demand for big data analytics grows, there is a shortage of professionals with the necessary skills and expertise. Organizations need to invest in training and development programs to build a skilled workforce that can effectively analyze and interpret big data. In conclusion, big data refers to large and complex data sets that can be analyzed to gain insights and make informed decisions. The use of big data is becoming increasingly common across a range of industries, including healthcare, finance, and marketing. However, the effective use of big data requires overcoming significant technical, ethical, and workforce-related challenges. By addressing these challenges, organizations can harness the power of big data to improve decision-making, drive innovation, and achieve competitive advantage.